So welcome to the Global Online Azure Bootcamp. My name is Carlos Mendible. I'm Technical Manager at Everest, Spain. I'm also Microsoft MVP Developer Technologies. And today I'm going to talk to you about Azure Kubernetes Service um, and all the features I've been learning about while struggling or trying to deploy production applications into a Kubernetes cluster. So first thing we're going to talk about is a little bit of the architecture. As you can see in the picture I'm showing, there is an Azure Manage box on the left and then a Customer Manage box on the right. The left side basically is where the cluster master nodes are. They provide the core Kubernetes services and orchestration, and it's absolutely managed by Azure. That means that you cannot access the master nodes directly. On the other hand, on the right side, you have the nodes that's managed by us, by the customers. And just to let you know, these nodes run a custom Ubuntu flavor, which is maintained by Microsoft. And the other thing you have to know is that you can only deploy the last 4 minor versions of Kubernetes. So for instance, if the last version is like 1.12.6, the latest version you can go and deploy will be 1.9, let's say .x. Okay. Then you have to be aware that there are some limits and resource reservations when you deploy an Azure Kubernetes service. The first thing is that the maximum number of clusters you can deploy per subscription is 100. The maximum nodes you can deploy per cluster is 100. And then for both basic networking and advanced networking options that I will talk to you in a few slides, the maximum number of pods you can deploy is 110. Then on resources, it's interesting to know that on the CPU side, you will have 60 milliseconds of the CPU reserved for Kubernetes services and orchestration. And on the memory side, what Azure Kubernetes services will do is to reserve 20% of memory up to 4 gigs. What this means is, for instance, that if you have an 8 gig node, you will have the 20%, which is 1.6 gigs of memory reserved for Kubernetes. But if you have a 32 gig node, then you will have just up to 4 gigs of memory reserved for Kubernetes services. What about networking? You have 2 choices when you deploy your cluster. One is basic networking and the other is advanced networking. With the basic networking, basically Azure Platform manage all the network configuration for you. You can define the configuration such as subnets, names, or the IP ranges assigned to the cluster. It uses the Kubernetes plugin, which is known to be, kind of slow, so you get a performance hit there. And you can expose your Kubernetes service externally through an Azure load balancer. And pods can access the resource on the public internet. On the other hand, the advanced networking can do pretty much everything up there, but it relies on the Azure Container Networking Interface, CNI plugin. It places your pods directly on your Azure Virtual Network. That means you can access other resources through your network, perhaps through an express route or a site-to-serve VPN, or even through a VNet peering. And it has a really better performance than the basic networking does. And the other thing, I'll speak of this in another slide, is that when you deploy your cluster with advanced networking, then you can also deploy Calico plugin, so you can deploy network policies on your cluster. On the storage hand, you can deploy Azure disks or Azure files. This is what Azure offers you for the cluster. And Azure Disk relies on premium storage. It is mounted as a read-write once, and only available to a single node. This means that if you need to share information through nodes, then you have to use the Azure files storage. Azure file storage, on the other hand, are based or backed by regular hard drives, standard storage, and it's used to mount SMB share, and of course lets you share data across multiple nodes and pods. Scaling is something that you should be aware of. You have various options for that. The first one is the horizontal pod autoscaler. In this case, the AKS use the horizontal pod autoscaler to monitor the resource demand and and automatically scale the number of replicas of your pods. What you do need for the horizontal pod autoscaler to work is to set the request and limits on your containers. If you don't do this, then the horizontal pod autoscaler won't work at all. And the other thing you can do is use the cluster autoscaler, which only works on role-based access control enabled cluster. And this will allow you to add more nodes to your cluster in an automatic fashion way. I haven't tried this one, so I can't discuss it any further right now. So what's that about pod request and limits I was talking about before? Pod request is the amount of CPU and memory that the pod needs, to start and to work. And pod limits is the maximum amount of CPU and memory that a pod can use. So on the right side here, you can see a YAML file. What is specified here for the container is the resource section. You can see a 10% of CPU time for the request of this container, and a 128 megs for the container. And for limits, it goes up to 25% of the CPU and 256 megas. What this means is that for a pod to be scheduled on a node, there must be at least this resources free on that node. And what the limits do is that for the CPU side, once you reach the limit, what Kubernetes will do it will try to throttle your container. So you may find a performance hit there. And what happens when the memory is going up to the limit, then it's possible that your container can be evicted. And if such thing happens, then if you are running, let's say, you're continuing through a deployment, then another replica will start again with the request that you have here. So let's see the horizontal pod autoscaling in action in this demo. I'll start this sample showing you this really slow function I have here, or method. It's, well, not that so slow, but CPU consuming. And this is an ASP.NET Core application I already built into a Docker image, push it to a container registry, and actually use these deployment here to schedule it in an existing Kubernetes cluster I have. And what I need you to take a close look here is at the resource section. What I'm assigning here is a 50% of CPU time, 256 megabytes for memory as the limits, and well, basically 25% of CPU as requests, and 256 megs for the memory. I think this one should be higher here, but for the sample, it's going to work out. So let's go and see what we have here running in the cluster. So first of all, let's see if the application is running. So we're gonna do get pods. And as you can see, we have the pod ID here running. What we're going to do is set on horizontal pod autoscaler for this application. Okay, so what I said here is that once we reach the 50% of the CPU, we're going to scale. We have a minimum of 1 pod, and we can scale up to 10. So let's see if this goes okay. And we're going to watch the horizontal pod autoscaler. So sorry. So there we're watching. We have just one replica. Let me run that again so it fits in the screen. Perfect. So there you go. We have one replica. We're not running anything on that pod right now. We're going to move to the low part of the screen here, and we're going to run that get query over and over. So calling that CPU intensive function that I showed you before. So this is going to take a little bit. This is going to take 10 seconds or a little bit more for each request to come back with one integer as response. There you go. And in a couple of seconds or perhaps a minute, we'll see the percentage here increase and actually the number of replicas go up. So let's wait a little bit. You can see here it went up 148%, so it should push the replicas up. And here we go, 3 replicas right now. If we let it run a little bit more, it will increase to 4 or more, and because it's actually spending many time on the CPU running the function. Whoa, 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 whoa. What's happening here? It's not your screen, but it's not either mine. This is just a joke. All right, let's continue. On the scaling side, you can also burst out with Azure Container Instances. This is done through extending the cluster, installing the virtual kubelet, or it's in preview. You can also install an add-on on the Azure Kubernetes service just for Linux, Azure Container Instances. And what this lets you do is to quickly deploy container instances without additional infrastructure overhead. What happens here is that imagine you have a cluster of 3 nodes. When you install the virtual kubelet, you immediately have a 4th node, which is virtual, and you can schedule things to run on that node. And what this does behind the scenes is create your instances through Azure Container Instances and run them. I'm not going to show you how to scale doing this, but I'm going to show you another feature and that's interesting, or maybe you can find it interesting, and it's that you can run Windows workloads using the Azure Container Instances. So let's see this demo about virtual kubelet and Azure Container Instances running a Windows workload. Okay, I already have the virtual kubelet installed on my Kubernetes cluster. So what I'm going to do is check for nodes here. Wait a second. Okay, and you can see the 3 nodes I deployed when I created the cluster, and also a 4th one, which is named the virtual kubelet, and it's actually not a virtual machine. We can go and check that on the Azure portal. This is the cluster where we're watching, and if we can come here to the scale properties, the scale blade, you can see we have actually 3 nodes deployed. So we're seeing here a 4th node in our cluster, and that's one of the magic things about the virtual kubelet. up here, you'll find a deployment that I've defined. I'm actually deploying just a nano server and IIS in this container, which is a Windows workload. And you can see we are selecting to run that on the virtual kubelet through node selector and tolerations. What I also did is expose that as a service named Win, and on port 80. And then we created an ingress using the Azure Application Gateway, and we exposed that with a /win path. So let's see if we can actually browse for that IIS on my browser. This URL is pointing to the application gateway I deployed. This is the path that I showed you before. So let's see if it takes us there. And here we go. So we're actually running a Windows container on a Kubernetes, on an Azure Kubernetes service through virtual kubelet, and it's going through an application gateway too. So this is a really interesting scenario you can explore when you go back and test drive these things for yourself. To finish with this demo, let me come here to the Azure portal and show you where this container is actually running. Remember, we're using this Kubernetes service here, the AKS NP. So we have in here, you know that Azure Kubernetes Services actually creates you another resource group where actually the nodes and load balancers are created, and networkings and NICs. So if we explore that one, we're going to find an Azure Container Instances here. You can see it here. And if we search for the containers, we'll see that we have the nano server IIS here running. So that's it. You install the virtual kubelet and you're able to run Windows workloads in your Azure Kubernetes service. What happens when you want to monitor and log your or do login in your Kubernetes service? Well, in Azure, you have a really simple solution, and it's to rely on Azure Log Analytics and Azure Monitoring Solutions. You will have to deploy a Log Analytics workspace. What this does is deploys a daemon set inside the cluster, and something that is new and you can find in Grafana 6.0 and later is that it has a plugin for Azure Monitoring, Log Analytics, and Application Insights. So let's walk to this on another demo. We're back here and in the AKS NP Kubernetes service cluster that I was showing you before. As you can see, we have monitoring containers here and view logs. Let's see the first one. It's going to take you here in Insights, and we can see it's showing us the CPU utilization, the memory utilization here. We can check the nodes for more information. You can actually see the virtual kubelet here, which is pretty amazing. And we can go to the containers tab and see what's deployed. You can see the OMS agent, which is the agent that actually collects the data that's being shown here. Well, and many other of the things we have deployed in the cluster. Okay, so let's go to Visual Studio Code. And as you can see, I have a config map here, which is the one I use to deploy the Helm chart for Grafana on the cluster. You have to set the subscription, tenant, client ID, the ID of the log analytics workspace, and also, of course, the secret that you use to connect to that workspace. And let's check again for the pod in the cluster. Oh, sorry. Use the pods. You can see the engaged Turkey Grafana pod running here. Let's find it on the Kubernetes plugin here in Visual Studio Code. Here it is. So what we're going to do is a port forward so we can connect to it. Sorry. Let's wait for a second. Start running. There we go. And let's browse through it. So here we are in Grafana. Let's go for the Azure dashboard. You can see I already added one that's showing the memory on the cluster, and down here you can see the pods in ready state. So it's been bursting, and you can go through it if you want. And you can actually add for instance, another panel. And I'm not going to do it right now, but it's just to show you that you can use application inside Azure Monitor or Log Analytics here, go through the different resource groups, namespace, and resource names and metrics to show. Let's see. If you choose Log Analytics, then it lets you create a query. Okay, so what happens if you want to provide granular filtering of the action that users can perform using role-based access control? What you do basically is enable role-based access control on your cluster, which is done on creation time. And actually, you can also integrate it with Azure Active Directory. On first Kubernetes control connection of the user, it is prompt for authentication, and it has to use its Azure Active Directory credentials to log in into the cluster and to be able to access the resources that are available for that user. Okay, so this is really interesting. Here it is, the network policies. I was talking to you in previous slides. You have to be aware that this is in preview. And what this basically lets you do is, constrain what pods can do inside your cluster. By default, what happens is that any pod can send and receive traffic without limitations. What you can do with network policies is try to constrain that, secure traffic between pods, allow or deny traffic based on settings like labels, namespace, or traffic ports. And this is done through Calico on preview. You have to do this deploying that plugin specifically. And well, as a side note, I couldn't deploy this for a cluster, for the latest cluster of for the latest Kubernetes version, but I managed to do it for a 1.11 Kubernetes version. So, this is something that's in preview. So if you want to try it, basically you can, for instance, deny any traffic that goes east-west inside your cluster. Let's say you don't want traffic between namespaces. And also what you can do is, for instance, you have the typical, front-end pod, back-end pod, and then the databases or something. What you can do here is restrict that only the pods with front-end labels can connect to the back-end labels, and only back-end labeled pods can connect to the database. And this way, if any if any part of that infrastructure gets compromised, or any part of that application get compromised, then it can only jump to one hub. Then you have the ingress controllers. You have like 3 ways to do this fast in your Kubernetes service. One is the HTTP application routing add-on. And what this does is creates an ingress controller and an external DNS. So anytime you publish a service, you get an external DNS name, and it's pretty easy to use. It actually deploys an Nginx pod, so you can also do SSL termination with that add-on. Another thing you can do is install using a Helm chart, sorry, an Nginx, and use Let's Encrypt to create SSL TLS termination for your cluster, for your services. And the third option I've been exploring is using Azure Application Gateway as an ingress controller, which lets you use a web application firewall or add a web application firewall to your cluster. And it relies on pod managed identity to work. So this way, the API server can talk with the gateway ingress controller and create the rules in the Azure Application Gateway in a very transparent way for you as the manager of the cluster, or the user of the cluster. When talking about secrets, yeah, you can handle secrets on Kubernetes with Kubernetes secrets, but many of my clients or customers use Azure Key Vault for this matter. And well, to use Azure Key Vault with Kubernetes, you have like two options right now. You can rely on on the Kubernetes Key Vault Flex Volume, which basically lets you access the secrets or the certificates or whatever you're saving in your cluster in your Key Vault. You can mount that as a volume and access those secrets from there. Or you can use pod manage identity, which is in preview. So what's that about, pod manage identities? When you use pod manage identities, the pod is assigned an Azure identity that lets them authenticate to Azure Active Directory and receive a digital token. Then that token can be presented to other Azure services and to check if the pod is authorized to access the service and perform the required action. Those services can be, for instance, and as you can see in the picture, Azure Storage, Azure SQL, Azure Key Vault, or any other service that can receive the token and actually authenticate you. So this is pretty neat. Actually, you don't have to have the keys for your Key Vault or SQL or Store account in your pod or even in your cluster. What you have is the identity created inside the Kubernetes cluster and an identity binding, and it works almost like magically. It lets you connect to the services and get what you need without exposing those secrets to the cluster, and that's pretty amazing from the security perspective. I will show you that in the next demo. Let's see the Key Vault pod manage identity sample. I've already deployed the pod identity, the manage identity in the Azure portal. You can see it here. I actually already deployed the manage identity infrastructure inside the AKSNP Kubernetes cluster also. And let's see inside Visual Studio Code that I created a pod identity YAML file that references the resource ID and the client ID for that pod identity we already saw on the portal. And I also created an identity binding that I deployed to the cluster, which points to the pod ID name, and it actually sets a selector. In this case, I use the requires vault value, and what that means, and let me show you that in the deployment file for the pod, is that any pod that I add this label with the requires vault, with the required vault value, will get a managed identity assigned, and that will let that pod ask for Azure Active Directory tokens and then talk with the services such as the Key Vault. What I'm gonna do in this sample is create a simple ASP.NET project that will be able to read configuration at startup from the Key Vault and read secrets. So let's take a look on the program CS, sorry. And what we are actually doing here is just instantiating a service token provider and giving that as a reference to the Key Vault client, and then configuring the Key Vault, and in this case the CFM Vault. They are already deployed, and I'll show you later in the portal. So the configuration reads all the secrets of this Key Vault. Okay, let me show you the Key Vault here. So here we're back in the Azure portal. Let me go. It's in a different resource group. The test here. You can see the CFM Key Vault. Okay, and we have a secret, which is called Bootcamp secret, and it's the only one that we have, and we're going to retrieve that value and show it on the screen. So going back to Visual Studio Code, we have a Vault controller, and this controller receives the configuration, and basically we read the Bootcamp secret here and return it as a value. I already deployed this to the cluster, so let's check and see how this looks like right now. As you can see, it returned hello from the CFM Key Vault. But what we're going to do is go to the Azure portal and change the value of the secret and see if we can read it again. So let's create a new version of it, and we're going to say something like hello from the global Azure Online Bootcamp. We're going to enter it as the value, as the new value. Let's create it. Okay, we have a new version of it. Let's disable the older version. And let's go back to Visual Studio Code. I'm going to come back to Kubernetes. As you saw previously in the program, I'm reading configuration on startup. So what I'm going to do is kill the pod. The deployment is it's going to have to create a new one. Okay, let's wait for it to be ready. There we go. So let's check it again. All right. And there we go. We have hello from the Global Azure Online Bootcamp value. So what's interesting is that I deployed this program to a container without any key that will allow it to authenticate with a Key Vault. So the way this is working is that the pod identity is asking Azure for a token, and that token is passed to the Key Vault client, and that's the way it can speak with the Key Vault. So in this case, the developers don't even know how the connection is being authenticated, or let me explain it better. They don't know about the credentials that are being used to authenticate the Key Vault. So this is interesting. You can do this with storage accounts. You can do it with Azure SQL. So this is very interesting from the security perspective. Okay, and to finish this review of what's available, what's interesting on Azure Kubernetes Service, I'm going to show you Azure Dev Spaces, which is in preview. You can do some iterative Kubernetes development in your cluster when you have Dev Spaces installed. You actually work directly against the cluster. You can debug using Visual Studio or Visual Studio Code. When you have Azure Dev Spaces, you can generate Docker and Kubernetes configuration as code assets. You can share the cluster with your team and work together with, in isolation without, having to mock dependencies or replicating components from one namespace to another. And that was actually trying to, show you this picture we have here on the right side of the slide. you know what this means is that blue line is like, let's say all the pods that are deployed, or all the services that we have deployed on the cluster, and it's everything is accessible through this URL here. And what Azure Dev Spaces lets you do is create a namespace, for example, for Susie, which is the developer here, and well, it will create a special endpoint for Susie to work. She will be able to deploy uh, her version of the bikes pod here, and then she can access that through susie.s, this URL here. And well, what will happen is that she will enter from here. This calls from here will redirect through her pod and back to the reservations. She can debug here, so you don't have to actually, duplicate or do anything with these pods here. She can actually debug her system here, or her change here, without affecting any other users that are actually using the my app URL up here. So let's see Azure that working is about. I Azure Dev Spaces web front end and a web API on a new AKS cluster named AKS AZDS, which is a shorthand for Azure Dev Spaces. And what the web API does is simply returns a hello from my web API message. And let me show you some things about this. When you run ACDS prep public, what this actually does is bootstraps your project, so you can get Docker file for development, and AZDS YAML file, and Helm charts, so you can actually deploy your project to the Kubernetes cluster. So I already run the prep, and I also ran for this web API the AZDS up, which actually does the deployment to the cluster in Azure. So I'm going to switch to the web API. Sorry, so the web front end. There we go. And as you can see here, we have a home controller, and then home controller says hello from the web front end, then calls the my web API, which is already deployed in the cluster. This is really important here. What we're doing is for adding the Azure Dev Spaces root as header to the requests, if it exists. Okay, and then calls the API and concatenates that in the message string. So I already deployed this one to the Azure Dev Spaces, and what we're gonna do is first of all list the spaces we have. So we have default and default Carlos. As you can see, the one that is selected default, and we're gonna go to the Kubernetes plugin here in Visual Studio Code. Let me show you the cluster for a second. And you can see that I have two namespace, one that's default and then a second one that is called Carlos. I'll come to this one later. So in default here, let's see what we have deployed. Oh, sorry, there's a typo there. And as you can see, we have two, one for the web API and one for the web frontend. Let me browse to the first one here. So here it is. And actually, if we go to the About screen, you can see that we have the hello from the web frontend and hello from my web API. Okay, so let's say I need to make a change here and try it. And what I'm gonna do is change this message here. Let me switch to my space. Let me change the message here, and it says hello from the global Azure online bootcamp. Okay, I'm going to put a breakpoint here, another one down here, and what I'm also going to do is, well, no, let me run it like that. So I just hit F5 so we can run and debug. And what you're seeing here is it's synchronizing file with the Azure cluster, with the Kubernetes cluster. It's using MySpace, it's installing the Helm chart, and it's building a container because there was some change. And we have to wait a few seconds, and then the application is going to be running on the Kubernetes cluster. So let's wait a second. It's almost ready with the build. Now it's waiting for the container to start on the AKS cluster. Let's give it a chance. You can see where it's running now. You can see it's running here. You can see it has a prefix now with my name and an S. It's running. Okay, so what we're going to do is we're going to take this URL here. We're going to copy it, and we're going to put the prefix we were at before. So now we have another version of the application with just my prefix here. As you can see, the other one is still running. We can go here. Sorry. We can go here. This is a default one. Default web front. So we're running. We go to the About page, and it says hello from web front end. And let's see what happened when I click on the About tab here on this one with my prefix. So first of all, you notice is stepping into the code. So I'm actually debugging something that's running on Kubernetes services. Let me run through the other breakpoint. So here in the stepping on the other breakpoint, we can see the view data. We actually can see and run through all the program here. Let's finish the request and go back to the browser. And as you can see, it says hello from the Global Azure Online Bootcamp and hello from my Web API. So what's happening here? The original application, if I refresh, it still says hello from front end, and there's a new pod running with my code that I actually can debug. This means that anybody that's calling the default URL has the default behavior of the application, and I'm the only one using this endpoint and debugging what's going on. So in this way, you can go and try out a pod and a new version of the pod without interfering with others, and so teamwork gets easier in the Kubernetes cluster. Let's see what this looks like in the cluster. Default here, if we go to the workloads, we'll have 2 pods deployed. Let's wait a second. This is taking longer than expected. Okay, so here in the pod section, we have 2 pods here, and let's change to my namespace. And now you can see that it only has the web front end published. This means that what's going on is this web front end is actually routing the traffic to the pod that is deployed in the default one because we use the Azure Dev Spaces route header here. So I invite you to understand how Azure Dev Spaces work and how it's gonna help you do teamwork on Kubernetes services and actually debug your programs inside the clusters. So that's it. Please feel free to go to the online documentation, scanning this QR code will redirect you to the correct place, and you will be able to read more about any of the features and more of the ones that I show you today. And well, that's gonna be it. Thank you very much for your attention during this global Azure Online Bootcamp. Thanks. Bye.